Good morning, everybody. We're going to talk today about proportions. Start solving some proportions. So, a proportion is an equation that shows that two ratios or rates are equivalent. Okay? So, it's very similar to a ratio, but we want to specify what this is. So, let's say, so it's an equation. It's going to have an equal sign that shows that two ratios or rates are equivalent. So, let's take a ratio. Let's say 2 to 3. 2 to 3 is a ratio. If I come up with an equivalent ratio, just like I would an equivalent fraction, by multiplying the top, let's say, by 2. Top and bottom by 2. So if I multiply both those by 2, I would get 4 over 6. So 2/3 and 4/6 are equal fractions, equivalent fractions. 2 to 3 and 4 to 6 are also equivalent ratios. Okay, we've checked that before by reducing and seeing if they reduce down to the same thing. Right, 2/3 is already reduced. This would reduce to 2/3. They're equal. Okay, so 2/3 is a ratio. Sorry, 2 to 3 is a ratio. 4 to 6 is a ratio. This statement, this equation, saying 2/3 equal 2 to 3 equals 4 to 6, is a proportion. Okay, so it's really easy to mix up proportion with ratio, but a proportion has to have two ratios and an equal sign saying that they're the same. That's what a proportion is. All right, equivalent ratios. The ratios in your proportions are going to be equivalent, same as equivalent fractions. Okay, when two ratios have the same value, when simplified, they're said to be equivalent ratios. Okay, now let's come up with a couple other examples of equivalent ratios, just so I can show you something neat that we're going to be using. Okay, so just thinking of a couple other ratios, let's say 4 to 5, and let's triple the top and bottom this time. So 4 times 3 is 12, 5 times 3 is 15. So 4 to 5, 12 to 15 are equivalent ratios. Okay, let's do 1 to 2, and then let's say 10 to 20. Okay, so I multiply top and bottom by 10. Okay, so here I have three separate examples of equivalent ratios. I want you to show you something that's true, and it's going to be really useful with these. Okay. What do you get if you do 2 times 6? 2 times 6 is 12. What do you get if you do 3 times 4? Well, that's also 12. Okay, we got the same number. Do you think that was a coincidence? Let's find out. What's 4 times 15? 60. What's 5 times 12? Why, that's also 60. Same number. Okay, but here, it's 1 times 20. 20. What's 2 times 10? 20. Okay, you can do this all day long, right? No matter what ratios you pick, as long as they're equivalent, if you multiply the diagonals, you'll always get the same thing. The number you get when you multiply the numbers that are diagonal from each other is called the cross product. Okay, so this is kind of a long and complicated definition. I'd maybe just use the one I'm saying in words. It's real easy to get kind of lost in the words here. But the cross products are what you get when you multiply the numbers that are diagonal from each other. So the numerator of one ratio times the denominator of another. Okay, and you can do it twice, right? Because there's two diagonals. So each ratio will have two cross products. If the cross products are equal, then the proportion, then it's a true proportion and the ratios are equal. So 3/5 and 21/35, if we wanted to check that, we could reduce it if we want. That's a method we still have. Another way we could do this is just by multiplying the diagonals and see if they give you the same thing. 3 times 35 is 105. 21 times 5 is also 105. So that tells me that these are a true proportion. These are equivalent. Okay. You might see if you do, these are both multiples of 7. So if you divide the top and bottom by 7, you would get this. And that kind of confirms that they're equivalent. All right, and we can use that idea to solve. Because when we're given a proportion like this, we can create an equation that we can use our equation solving skills to solve, okay, that we did last try. Okay, so if I have a situation like this, I don't necessarily know what n is, but I do know that when you 8 times n, gives you 8n, you should get something that's equal to 10 times 10, which is 100. So I'm just going to multiply the cross products and set them equal. 8 times n equals 100. Okay? From here, this is an equation I can easily solve using my train tracks. Right? N is being multiplied by 8. So I'm going to divide by 8. I get n equals 12.5. Okay, so 10 to 8 is an equivalent ratio to 12.5 to 10. Okay, let's try another one. So again, I just multiply the diagonals. 5 times x is 5x. 7 times 3 is 21. They're cross products, so I know that they are equal to each other. 5x equals 21 can be solved for x by dividing both sides by 5. You get x equals 4.2. Okay. So, kind of a shortcut you may be noticing here is we end up multiplying the two numbers that are diagonal from each other and then dividing by the one that's across from the x. So if you see that, feel free to use it. Okay, but this is the idea that we're setting up here. All right, so now that we got that idea, let's make it a little more complicated. So here we have an example of a proportion where we don't have just a number or a variable, we have a whole expression here. Okay? But we can use our equation solving skills along with this idea of cross products to still figure out what this should be. Okay? So let's start with the easy side. 5 times 9. Well, 5 times 9 is 45. That's one cross product. Okay, now that's got to be equal to the other cross product. Well, the other cross product is going to be this times this. So I'll do 6 times 7n plus 9 in parentheses. Okay. Now this is one of my more complicated expressions, but we have done ones like this. Okay. Remember, if I go back to my steps, I got to start by simplifying. I have parentheses here. I have to use my distributive property to get rid of them. Okay, so I'm going to distribute the 6. I get 45 equals 42n. Then 6 times 9 is 54. Okay, so 45 equals 42n plus 54. I don't have any more simplifying to do. There's no like terms. Okay, so I can go to my train tracks. I'm trying to get n by itself, trying to get this variable by itself. I have multiplication and addition. Remember, with two-step equations, I have to undo the addition first. This is that SAD map stuff we talked about. Okay, we're undoing in reverse order of operations. So I'm going to subtract 54 from both sides. And I get 42n equals 45 minus 54. I can think of as 45 plus negative 54. Adding two numbers with different signs, the negative is bigger, so my answer will be negative. If I want to know how much bigger, if I subtract these, I get 9. So negative 9. Okay. Last step, I need to get rid of the 42, so I'm going to divide by 42. Always have to do the same thing to both sides. Okay, and I get n equals, and in a situation like this, you can generally just leave your answers as fractions, though you do want to reduce them if you can. Okay, so instead of doing 9 divided by 42 and writing out whatever long decimal that is, I can just leave it negative 9/42. Again, don't get too hung up on if the top or the bottom is negative. I have a negative divided by a positive, so my answer will be negative. So just leave the negative on the fraction itself. Okay, then I want to think if I can reduce. So if you look for a number that goes into 9 and 42, hopefully you'll recognize that 3 goes into both of those. So I'm going to reduce this by dividing the top and bottom by 3, which will give me 3 over 14. Okay, so n equals negative 3/14. Kind of ran out of room there. There's my answer. Okay, so if I plugged in negative 3/14 here, I would get an equal proportion. All right, so there's a little bit more work there, but it's just using the stuff that we did last try. Okay, so hopefully you remember how to do this. All right, let's do another one. All right, I'll do the harder side first this time. So again, we're just setting up our equation by multiplying the cross products and setting them equal. So 9 times r minus 3 equals 2 times 4, which is 24. Okay, I got parentheses, so I have to distribute to get rid of those. 9 times r is 9r. 9 times negative 3 is negative 27. Okay, so I got rid of those. Now it's SADMAP. Okay, 9r minus 27. I got to add 27 first. So if I add 27 to both sides, I get 9r equals 24 plus 27 is 51. Okay, last step, I got to get r by itself, so I divide by 9, and r equals 51 ninths. So again, I don't want to necessarily do a decimal, but I do want to simplify this. Let's make it a mixed number first. So 9 goes into 51 5 times. Right? 9 times 5 is 45, with 6 left over. So 5 and 6 ninths. Okay, then hopefully we can see that 6 ninths can be reduced. Divide the top and bottom by 3, and you get 5 and 2/3. So 5 and 2/3 is my answer for R. Okay. Right. So let's do maybe a couple of these together. And then, well, why don't you try 5 and 6? So let's pause the video here, and you try 5 and 6, and we'll see how we did. All right, so let's check in. Hopefully these are the answers that you got. 5 was pretty straightforward. 4 times x is 4x. 3 times 8 is 24, so 4x equals 24. You had to divide by 4, and you got x equals 6. Okay. One thing also you might have noticed if you're using your proportional reasoning and equal fractions ideas, if we're thinking about rewriting 4/3 as an equal fraction, okay, with 8 on top, well, to get from 4 to 8, you just multiply by 2. So 3 times 2 would give you 6. All right, so same answer. Sometimes it can be solved, kind of shortcutted if you can use that proportional reasoning idea. All right, not so much with this one. All right, so if we look at this one, we have 10 times b plus 5. I chose to use a capital B because my lowercase b was looking like a 6. Okay, so 10 times b plus 5 equals 7 times 5, which is 35. Okay, so I had these fractions, these parentheses I had to get rid of first. So I distributed 10b, and then 10 times 5 is 50, so 10b plus 50 equals 35. If any of these pieces in this equation solving is a little rusty for you, you're going to want to go back and look at that again. Okay, we stressed this a lot when we're going through this unit. Right before Christmas break. Remember, equation solving is central to algebra. This is going to come up in a lot of the things probably most of the things you do going forward in math. Okay, so this kind of stuff, this kind of work is going to be happening over and over. So we need to get very comfortable with this if we're not there yet. All right, so to get the b by itself, I have to subtract 50 first. Okay, remember we're doing order of operations in reverse, so I undo the adding first before I undo the multiplying. Okay, so that gives me 10b equals negative 15. 35 plus negative 50 is negative 15. Okay, last step, divide by 10, I get negative 1.5. Okay, so negative 1.5 would make this statement true. Okay, if we kind of check that out, You might notice that the top here is twice as big as the bottom. So 5 is half of 10. So we should expect the bottom here to be half the size of the top. Well, half of 7 is 3.5. If we make b a negative 1.5, that's exactly what we would get. Okay. So you can check that if you want, but that does work out. All right, let's try a couple more. So we got 9 times b minus 1 equals 6 times 7, which is 42. Okay, well, 9 times b is 9b. 9 times negative 1 is minus 9 equals 42. Okay, do train tracks. I got to add 9 first, get rid of that minus 9. Gives me 9b equals 51. And last, I'm going to divide by 9. Okay, again, I can leave it as a fraction, but I'm going to want to simplify. 51 ninths. Okay, I actually think I had this one before. I can divide both of those by 3. And that'll give me 17 thirds. Okay, then I got to make it a mixed number. 3 goes into 17 5 times with 2 left over. So 5 and 2 thirds. Okay, last one. We got 8. Well, let's see if we can use our reasoning skills here. So I notice the top is 4 times as big as the bottom. Okay. So that means that has to be true here also. So that means the bottom, if the top is 4, the bottom has to be 1. So if you think about what number m would have to be in order to make this 1, I think 9. All right, 9 minus 8 would be 1. Okay, so I'll go through the process of solving this, but I'm expecting my m to come out to be 9. We'll make sure that happens. Okay, so I do 8 times m minus 8. That's this cross product, and that's got to equal 4 times 2, which is 8. Okay. So let's distribute. 8 times m is 8m. 8 times negative 8 is negative 64. That equals 8. Let me do my train tracks. I have to undo the plus minus first. So add 64 to both sides. That gives me 8m equals 72. And then lastly, divide by 8. I get m equals, what do you know? 9. Okay, so 9 is my answer, and we've already checked to see how that makes this true. Okay, 4 to 1 is the same as 8 to 2, and MB9 would make this bottom 1. All right, so a lot of this is stuff we've done before. The new part is we're solving the proportion by multiplying the diagonals and setting them equal to each other. All right, so good luck. Make sure to ask if you have questions.